So good afternoon everyone. So this is Eswar from Computer Science Department, JNTU College. So today I'm going to discuss about basic information about UML diagrams. So before explain diagrams, I want to explain what is a UML. So UML is nothing but it is a one language like our English or Telugu like that. So here it is a visualization purpose and for specifying and visualizing and constructing and document the artifacts of software systems, business modeling and other non-software systems. So this is one standard language to visualize the things that will be constructed in software industry. For example, if you take a system, for example, machine, if you want to develop a computer, so what are the things are needed for developing a system? We need some software and hardware things, right? So how they are connected, how they are interlinked. So for visualize the things, we are using some notations that is called that UML diagrams. So the UML is a very important role, uh, playing very important role developing a object-oriented software and the software development process. So the UML uses mostly graphical notations like class, uh, object, interface, state, sequence. So there are different notations, graphical notations to use to express the design of a software projects. So using this AML, that is Unified Modeling Language, helps a project team communicate. So project team means like developer or software engineer or architect, programmer, tester, different stakeholders. They communicate with each other and develop a good project with the help of UML diagrams. So the UML diagrams, the main aim of UML diagram is to visualize the things what you are using in the develop a project. So this is some basic information about what is a UML. And then now the next thing is different types of UML diagrams. We have structural, behavioral and interaction. Structural diagrams nothing but so it shows the structure of a diagram, structure of a system. So these are the different structural diagrams. One is class, component, deployment, object, composite structure and package. The second thing is behavioral diagrams. So behavioral diagrams nothing but it shows the behavior of a system. Like for example, system performing some functions like operating and show the output and internally they are performing different operations. For example, if you take a teacher or student is a class. Now, what are the operations performed by, or what are the operations or function performed by teacher or student is teaching or student is attending the classes. So these are some functions. So that means it shows the behavior of a class. Okay. So these are the some behavioral diagrams like activity, state machine, use case, interaction. So next thing is interaction. So interaction nothing but communicate between more than two things. More than two things like communication, sequence, interaction, and timing diagrams. Now I will explain each diagram. So what is a class diagram? So class diagram nothing but it is a different classes, how they are connected and what relationship we are using in between different classes. For example, college information system. We are taking one example is college information system. In that we need student information. How you get the information? So here one example is student is a class. So what are the attributes for class? Like student name, ID, address, etc. So what are the operations performed by class student like reading, writing and attending the exams. If you take another class like teacher. So teacher also having some designation, ID, name, address. So followed by some operations like teaching and take the attendance. So like that. So these are the two classes we have taken in that example. And then what is the relationship between student class and teacher class? So based on the situation, we differentiate the relationship. So what is the relationship here? So relationship nothing but a connection between two things, how they are connected. So like different relationships are there, like dependency, realization, association, aggregation. Based on the situation, we can take a different appropriate relationship to give that, to know the behavior of a class. Okay. So this is one example for class diagram. So we are taking student is a class, another thing is course. So a student enroll a course and date and different operations performed in enrollment classes, drop, cancel, enroll the course. So course is another class, enrollment is another class. Here, how they are connected? A student is connected to student take the course. If the student is interested to take a course, you enroll into the that course, like give the name. So here the consent is must be 18 years of age or older. So student class diagram nothing but connecting the different classes using some relationship. So this is a class diagram. In that, so employee, team, airplane, and component. So here it's showing 0 ones, 1 to multiplicity, 0 to multiplicity. So these are the multiplicities we are using in UML diagrams. So multiplicity nothing but how many members are there in that class, how many members they are using, like not only person, a system or subsystem. Okay. So here the team, that is employees, build a aeroplane. So that is a class diagram. Now second thing is component diagram. This is another structural diagram. So this diagram shows the dependencies among software components, including the classifiers that specify them. For example, if you implementation classes and the artifacts that implement them, such as source code files, binary code files, executable files, scripts, and tables. So this is one example for a component diagram. Here we are taking one online ordering system. Example is, so customer order something, so using some app. So like for example Zomato, whatever apps you are available. So using app, you can get the data from database, like how what items are there in database, like in that hotel. The customer choose whatever interest based on that. So the customer take the and order something, like for example kebab or chicken something, or what interested customer interested based on that. So we are providing your items are first collected, items are collected, and then pay the amount. So here in the payment option, we need to provide some security, like security infrastructure or persistence, that is I encryption, I persistence. These are the interfaces we are using. So these are the components basically we are using in online ordering system, like Apache Struts, online ordering, shipping, customer order, delivery. So these are the components used in online ordering system. So next one is deployment diagram. So deployment diagram depicts a static view of the runtime configuration of hardware nodes and the software components that run on those nodes. So deployment diagram shows the hardware for your system, the software that is installed on that hardware, and the middleware used to connect the separate machines to one another. So actually deployment nothing but, so for example, if you want to buy or deposit amount in a bank. So what are the things are involved on that deposit amount? Like customer is the main thing, and the bank manager and bank server. That is so you need, the bank server nothing but it contains the customer details, right? So here in the final stage, who are the persons or system or subsystem are involved on that uh, to perform a operation like deposit. So for in that deposit transaction, the persons or system involved are bank manager and database server, user like customer. So so these are the things actually in a deployment stage. So we are link the and we are give the some relationship to those systems or persons, that is customers. So that is about deployment diagram. So this is one example comes under the deployment diagram. So here in right side we have a DB server and mainframes, that is course management legacy system. So here one middle thing is container that contains a student and seminar and schedule. So here student want to give some seminar. Uh, so how things are happen here? So student can admin, student can register the in that process and then give a schedule. So these are the things actually involved in the deployment stage. Okay. Next, this is deployment diagram. So we have desktop, different like database like MVS maintains data warehouse, operational databases, payment processing gateway. So in the right side we have a DB different databases and so we are logging into different devices like desktop, mobile PC, PDA client. So that we are using application server in a system and so this is the deployment diagram. So for applying or register a student registration into some application seminar. So this is one example for deployment diagram. Next, object diagram. So already know that object is nothing but instance of a class, right? So are useful for exploring real world examples of objects and the relationship between them. It shows instance instead of classes. They are useful for explaining small pieces with complicated relationships, especially recursive relationships. So this is one example for object diagram. So here taken maths department. In that we have a statistics and math again divided into applied maths and maths education department. So actually the whole class name is here department is a class. So what is the instance of a name? So math stat is the instance of name. Department is a class here. Again math instance again divided into two applied math and math education. So this is a object diagram. Next, activity diagram. So activity diagrams helps to describe the flow of control of the target system, such as the exploring complex business rules and operations. Describe the use case also the business process. It is object oriented equivalent of flow charts and data flow diagrams, that is DFD diagrams. When you take DFD diagrams, DFD diagram shows the so data flow diagrams means, so if you take one example like creating a machine. So in that we are taken some process to create a machine. So that means so what exactly what is the flow of a data here? So DFD nothing but so how the actions are occurred one by one sequentially one by one. That is the data flow diagram. So here also this activity diagram shows the what are the different activities are performed and performing one by one. For example, from starting to ending, each activity you can represent using activity diagrams. This is one example for an activity diagram. So a user or customer want to order something. So what is the process going on here? First thing is requesting for an order. So if we receive a order and then close. So if order is full order, order accepted. We have two things are here, decision table. One is order rejected or order accepted. So when order is rejected, if items are not available in that hotel at the time order is rejected. So if our items are available, so order is accepted. And then if items are prepared, and what is the next step? Ship order, and then can pay the amount, like it generates the invoice. So after that we can make the customer make a payment and then accept the payment. Finally, if your payment is successfully completed, order is shipped, and finally you close the your order. So this is step by step procedure. Each activity you have mentioned here. So this is activity diagram. It is comes under the behavioral diagram. So this is how activities are performed in each state. So what are the stakeholder state? So stakeholder prioritize the enterprise requirements and describe enterprise requirements. In requirements analysis phase, so what are the requirements in the enterprise requirements? In the enterprise architect model, enterprise business architecture, project teams, enterprise technical architecture. So this is about activity diagram. So next thing is state machine diagram. So state machine diagram can show the different states of an entity, also how an entity responds to various events by changing from one state to another. The history of an entity can best be modeled by a finite state diagram. So state diagram nothing but, so we are event here, one word is event. So for example, we are conducting some event like dancing or like playing. So for example, if one event is occurring in the college, so after some time same event is occurring in outside the college. So here the state is different but the activity is same. Okay. So this is one state machine diagram. So entry state are start, exit and stop. So if you dial a digit like 10 digits, so the number is correct if automatically you start a or dial a call. Otherwise it not dial. So if your number is valid, the call is dialing. So here the states are different. Like in starting state, you have entry and start dial tone, exit, stop dial tone. In partial dial, you have entry, number is appendix. So if digits are 10, it is accepted, otherwise it is not accepted. So this is another example for state machine diagram. So a student enrolled into exams, if you started the course, so after that being taught, classes are ended. So if you're not enrolled, they are not enrolled into the classes. So if the classes are less than 0, seminars are 0, student are dropped from the classes. So if the student is are eligible for exams, they are writing for exams, that is final exams. So this is a state machine diagram. So what is the use case diagram? Next one is use case diagram. So use case diagram describes the behavior of the target system from an external point of view. Use cases describe the meet of the actual requirement. So here we have three things are discussing in this use case diagram. One is use cases. So use case nothing but a activity or functionality or operation. So actor nothing but a person or system or subsystem. They are performing some action. They are playing a role. They plays a role in one or more interaction within your system. So actors are drawn as a stick figures. So next one is associations. So this association is a one relationship used between actors and use cases are indicated by solid lines. An association exists whenever an actor is involved within an interaction described by a use case. So this is one example for use case diagram. So here we taken patient is a actor and make a payment. Action performed by patient is make a appointment. So that is here using a solid line, that is association. So that is communication. Make appointment is a use case. So this is use case diagram. So customer want to check the status and place a order and fill the orders and establishment a credit. That means make the payment. So here on the other side we have three actors like salesperson, shipping clerk, supervisor. So the salesperson communicate with owner in placing order and checking the status. So this is about use case diagrams. So this is a whole diagram of use case diagram. So we have different actors and different use cases. In these actors and use case, we have some relationship in between use case and actors. Next one is communication diagram. So communication diagram, we have two types. One is sequential, another one is collaboration. So sequence diagram, this is one communication diagram. Here we are using some like actor customer and objects are order, product, process order controller, fill button, order detail, and there is a some relationship or messages in between those objects like fill order, set status, update inquiry or update quantity, change status. So these are the different messages in between those objects. Here customer created a process. So next one is sequence diagram. So sequence diagram models the collaboration of objects based on a time sequence. It shows how the objects interact with others in a particular scenario of a use case. So this is one example for sequence diagram. A student enroll a seminar and the course here a seminar, from seminar to course we have a one message that is each student is eligible. The student is above 18 age if at the time or is eligible for enroll into that course. Not only age, so age is a constraint here. You take another constraints like is got 75 mark, above 75 percentage, or also if a student is third year at the time only can eligible for course. So you have these are the some constraints. Okay, and then the course gives the seminar history. So and then based on that the student can attend the seminar history. So if eligible the course gives eligible status, finally student enroll into a seminar. So this is what exactly a student can perform, not only perform like how they are enrolled into that course. So this is a sequence diagram. Here this is one by a step-by-step procedure. Next, timing diagram. So timing diagram shows the behavior of the objects in a given period of time. Timing diagrams is a special form of sequence diagram. So the difference between timing diagram and sequence diagram are the axes are reversed so that the time are increased from left to right and the lifelines are shown in the separate compartments arranged vertically. So this is what exactly timing diagram. So printer, the PC. Taking two different examples like, so in printer idle receive data printing, in the PC you have idle processing report. So thing is same but actions are different here. This is what exactly this example tells about timing diagram. So for example our aim is to teaching a seminar. So based on that you can divide the schedule. So here we can divide this diagram into two things. One is instructor professor and teaching associate student. So the timing is same, that from October to October 15. So this is about timing diagram. So next one is interaction overlay diagram. So interaction overview diagrams focuses on the overview of the flow of control of the interactions. It is a variant of the activity diagram where the nodes are the interactions or interaction occurrences. It describes the interactions where messages and lifelines are hidden. This is one example interaction overview diagram. So interaction diagrams are nothing but there are two types. One is collaboration, other one is sequence diagram. These two are isomorphic because isomorphic nothing but you can change diagram from one diagram to another diagram without change the information. So this is UML diagram hierarchy. So diagram they are different divided into structural diagram and behavioral diagram. In structural diagram, so that is a class diagram, component, object, composite structure diagram, deployment diagram, package diagram. When it comes to the right side, that is behavioral diagram, activity diagram, use case diagram, state machine diagram, interaction diagram. Uh, Again, interaction diagram divided into sequence, interaction overview diagram, communication diagram, and timing diagram. So this is about basic information about UML diagrams. I hope you understand. So up to now I explained about different diagrams like what is a use case and what is a class, what is a sequence, activity, state chart, component, deployment, object. Actually, these are the 9 diagrams mostly were used in UML diagrams. So this is about UML diagrams. Thank you.